in today's session, we'll be quickly going through the solution part because it is necessary, right, that we try to provide you some sort of guideline in terms of the answering. Okay, so because of that, I'm actually spending an extra hour or so, right? Maybe this will extend 1 or up to 2 hours, right? In which again I'm giving a chance for you to ask the questions and clarify the doubts in basics itself. Mostly in the upcoming assignments, will never be having any session discussing the solutions. Okay, so this is the one and only options that you get, right? Just to clarify the doubts whichever you had, right, in the assignment solutions. So this is again a key solution, whatever we are going to discuss today. You can see the questions. I'll try to write one of the answers, which is again my way of answering, right? That doesn't mean that whichever you have answered is wrong, right? I see few of you have tried different ways presenting your answers. I really appreciate that. Okay, don't go with the straight method, explore and try to give your answer. So this is what I highly recommend, and I can see that many of you have done that. All right, so let's start answering the questions one by one. Meanwhile, if you have any questions with what I type or you want to discuss anything, right, other than what we write related to the topics, yes, please go ahead. All right, okay, so we'll start with the first thing, that is import a NumPy as an NP. So this is straightforward. Import NumPy as NP. So again, that was an exercise just to make sure that, right, how to import NumPy and what is a very standard alias that's being used. So as you know, it is NP, right? So the next question is that create a 1D array, right? So we want you to understand that how to create an array of size 1. And you can check its shape, right? Saying that, okay, whatever I have created is going to show the shape as 1. All right, so let's try to do that. So capital A, I can try to write as np dot a range. Just mention that, okay, I need 10, right? So this is going to create an array. And if you want to visualize that, you can simply write, you can simply write this. So it's an array. Also, you know that there is a method called finding out a shape, right? A dot shape. If you call that, it will show you, right, what is the shape of that. So that's an optional case for you to understand, right? So then create a 2-dimensional array, right? So I saw many methods where people entered the values by themselves, like 1, 2, first row, then 2, 4, etc. Absolutely fine. I will suggest something like this. When you don't have anything in your mind, right, what to generate, simply go with say np dot a range, put some number, maybe I'll put say 25 numbers. I want 25 numbers. In the sense, this creates 1 dimension. Do a reshape. Okay, so recall what reshape is going to do. I'll just say that make me 5 cross 5. So you can see that it generates a 5 cross 5. All right. So if you give say 36 there, right, np dot a range 36, right, you have an options like you can enter 9 into 9 comma 4, 4 comma 9, or 18 to 218, right, etc. Right. Anyway, any of those answers will be considered as a correct answer. Okay. All right. Then let's proceed further. So we'll move further to the fourth one. So create an array of 10 5s. So there should be 5s. All numbers should be 5s. It has to be, this has to be, the count has to be 10. So you actually have two options, right? One is np dot, I can say, yeah, ones. In a sense, this creates ones, but I don't want ones, but I want 5. So what you do, you can multiply this. So into 5. This is one method, right? I see few of you have written the standard method, right? So the standard method, I'll write the answer here. So this is also acceptable, right? This is also right. So np dot full is the right answer. That's also correct. Okay, so can write So I want 10 and the value to be entered is 5. This is also going to work. Okay, absolutely fine. So that was exercise number 4. Then let us move further. The exercise number 5. It says that create an array of 30 zeros. All right. So that has to be np dot zeros 30. So you can print this out, or if you want to check the shape also, absolutely fine. Right. So entering is not an answer, not a suggested way. I can see very few of you try to enter then 30 zeros, right? So I don't suggest that. But anyway, I cannot say that that's a wrong answer. But if at all I asked to create 1,000 zeros, then that's not going to be an answer. Okay. All right. So next question, if you see, create an array of odd integers from 20 to 40. I'll write the easiest one. Many methods do exist. Okay, so people also try to do this using loops, right? That's absolutely fine. You got an answer, that's right. But see, the Python is a language which tries to make your work easy, right? What I suggest is if you really need the loops, then only apply loops, or it's actually called as Pythonic way of programming. So the Pythonic way of programming is nothing but until and unless it is absolutely necessary, don't go for loops, don't go for conditions, don't go for if else, etc. That's actually right. It's considered as time consuming whenever it comes to the precious time of your processor, right? If you are unnecessarily using the loops, unnecessarily using the if etc., you are wasting the time of your computer, right? So it may not be a big issue when it comes to the very small 1-2 lines of code. Okay, but when ultimately you look at your ultimate goal, you are going to learn the machine learning where you are going to write large programs, and right, we are trying to implement something which is very practical. Also we are trying to implement which is in real time, right? Data set is too huge, number of lines of code, again that's also going to be a large number. In such cases we should not waste the time of the computer, because you will see that in some of the cases computer the fastest program that you can write will run for 2 days, right? One program 2 days. It's not it's not a rare case. You will see that. So under such conditions, right, already it is running 2 days, and you see that that's the fastest program one can write. If at all we waste time, that may go say 4 days, 1 week or something, correct? So that should not happen. That's why I'm trying to eliminate the small mistakes, small errors which we make, right, in the initial stage itself. Okay, so just remember, unless and until it is absolutely necessary, we should not use the loops. Okay, this is one example where you don't have to go for any kind of loops. Directly I can get an answer, right? So np dot, you can create a range. Okay, create a range, and the starting number 20 to 40, only odd numbers, means you don't have to start from 20, you can start from 21. You can say that my last number is 40, right? Because 40 will be excluded, and you can say that give increment of 2. So just see 21 to 39, all odd numbers have been printed out. See, we never use any loop. Okay, that is very important. Okay, all right, let's proceed further. Want to create a 5 into 5 identity matrix, right? We have two options. The first one is np dot EYE. I see very few of you using this. I think I had given an example, right, of this. All right, even if you are not doing that, I can show you another method, right? This is called as identity. There is a built-in function called identity that also will work. np dot, there is what is called as identity. You simply have to enter 5. Okay, so both of them will work, and that's right. Then look at the next question. Generate an array of 20 random numbers sample from a standard normal distribution. So standard normal, we had not discussed. So this is actually an assignment question. You had to search something. You may have to refer to the documentation which I had given initially, saying that, okay, if you have any doubt, you can go to this API. I think I had shared a online link somewhere. You can go and search, right? So this is such kind of exercise. So few of you have done that. I appreciate it. Okay, np.random. np.random is uh, a, this is where you will find out the random number generators, right? Anything related to the concepts of random. But right now I'm looking for a specific case that is called as a standard norm. So if you remember, we have discussed and we have used the normal distribution. So there is a small difference between normal distribution and the standard normal. Normal can have any mean, any variance, right? It can be, you can locate that at, right, anywhere on your x-axis. But if you remember the fundamentals of probability, right, or probability distributions, you should be able to remember that the standard distribution is something, right? So my distribution is bell-shaped, and it may be located anywhere, right? I'll try to bring it to origin. So the center at 0, mean is 0, and the standard deviation is, the sigma value is equal to 1. Any distribution you convert into this format is what we call as the standard normal. So standard, you can see that there is a function called standard normal. So this is the one which I expected people to use. And yes, you can see that when I say 20 random numbers are generated. Again, since the mean is 0, I should get few positive numbers, few negative numbers as well. So you can see that, right? This is how we generate the random numbers, and specifically standard normally distributed random numbers. Size, you can, anything you write in the bracket, it will create. If you enter 2000 numbers will be created. Okay, so that's the one which I want you to remember, and I want you to explore, right? So what are the other random distributions you can generate, right? This is what I want you to know. So right now you know two of them. One is a normal distribution, second one is standard normal distribution. Other than this, you know, you already have studied that in your engineering maths, saying that, okay, so there is what is called as a Poisson's distribution, binomial distribution. Okay, I remember exponential distributions. Many things do exist. So I suggest you to at least to know that there is a function like called this inside the random, right? Inside the np.random. So whenever you face that, right, in future, right, whenever you deal with the data, right, I want you to remember that. That's the fundamental idea behind including this question in your assignments. All right. Next. Let's go to the next part. So you can see that, right, the question number 9 says that you need to create a list first and convert that list into, right, the NumPy array. Absolutely fine. I think I can call list 1. Let's create this first. List 1 is equal to, simply create a list, right? Comma 5. Let's say this is a list. Okay, this is a list 1 which we have printed. Okay, now let me convert that into, right, let me add a cell here. Okay, so I will simply perform np.array. Okay, I can simply call array of, you have to tell the name of the list. So you can see that output at line number 11 is a list, and output at line number 12 is an array. Okay, all right, let's go ahead. So let's move to the next question, that is exercise number 10, right? Okay, so create a 4 into 4 into 4, right? So it's actually a 3-dimension, 4 into 4 in the first page. Like that, I need 4 more pages behind this. So page number 1, page number 2, right? And I can give page number 3 and page number 4. So 4 such pages are required, right? It's saying that you have to create it in a random fashion. You don't have to put a specific values over there. Simply, you should know how to create that. That's the motto. So np dot random dot, you can use RAND. I'll show both of them, 4 comma 4 comma 4. Okay, let's see this. This actually, oh, my mistake. np dot random. I should be more careful, right? While entering, yes. So you can see that this is np dot random dot rand. Okay, so this creates the values between 0 and 1. RAND is a function, creates 0 and 1. Whatever size you specify, it will be created. I'll also show you another option. This is also optional for you. np dot random dot random. Okay, this is other function. Simply enter 4 comma 4 comma 4. Oh, again, I made a mistake. Oh, I have done a mistake here. This means only one argument, means everything should be inside a bracket. So now you see 4 comma 4 comma 4, which is then entered inside the brackets, right? It is a single entity. Okay, right. So we can see that either of them, whichever you want, you can use it. All right. Then the next question, question number 11. Create a 10 into 10 array with random values and find the minimum and the maximum value. Okay. Yes. All right, let's go with that. Few of you have tried well to implement this, and you had an idea that okay, there will be a function, right, which I'm supposed to use, right? That's good. Let's see. So let me create an array first. So b is equal to np dot random. Mistake. np dot random dot rand. I'll specify 10 comma 10. Okay, that's B. Let me check B first. Okay, so this is B, 10 cross 10, so totally 100 values are there. So inside this, I need to check out the maximum value. I should use B dot or np dot max of B will work. Okay, simply I write B dot max. That's the highest value that is present. B dot min is the other one. So, right, np dot min of B will also, right? There are multiple ways, right? So most of you tried the other one, right? So that's why I'm showing you the one which you have not tried, right? So that's why this is also a useful, right, approach. Okay. So the next question. I want to create a 8 into 8 what do you call as a checkerboard matrix. What do you mean by a checkerboard matrix? So this is something like I should have 1 0 1 0 1 0. So below that, if every 0 you should have a 1 in the next line, every 0 you should get a 1, every 1 you should get a 0 there. So I should specify I want to repeat this. So if you simply specify zeros and ones only for one row, that is not going to work. I have to tell that, right, this is the pattern and repeat that pattern so many times. So yes, I can see that few of you have referred internet and try to write an answer. Absolutely fine. Okay. So yes, so one of the answers which I obtained, I actually like that. I'm trying to give that answer. So this is np dot tile. So there is a function called tile, and in tile I can actually specify, see my first one I start on 1, next is 0. Okay, this is my pattern, and I say that in the next line I want a 0 comma 1. Okay, so this is my pattern, 1 0, below that 1 I have a 0 1. So 1 0 0 1 is a 2 into 2 pattern. This I need to repeat so many times such that, now I'll tell you the condition. The condition is that I need to get 8 comma 8. Let's check. 1 2 1, 2, 3, 4. Okay, it's bigger, right? Sorry, it's my mistake. Then I think I can just do 4, comma 4. Because already I'm writing 2 cross 2, right? Oh, okay, I wrote it just 4 cross 1. Okay, my mistake. Let's correct. So this should be 4 cross 4. Yeah. So 8 cross 8. So horizontally 8, vertically 8. So after every 0, irrespective of which direction you read, horizontally or vertically, 1 0 1 0, it should be the same case. Irrespective of whichever line you take, whichever row you take, it should be 1 0 1 0. Okay, so that's what is called as a checkerboard this thing. Okay, matrix you can create by using this. So I wanted you to explore about this particular function called np.tile. Yes, I can see if you have done that. All right, let's go further. They have given 2 different, what do you call, arrays, and it was required that you are supposed to do the following operations. All right, so let's try to write them one by one. So it says that create a matrix A. A is equal to ANP dot ARANGE 1, comma 6. That is A. Let me print out and check that A. And let's do this. So that is B is equal to NP dot range. This is starting from 6 all the way till 6, 15, yeah. Then 2. Okay, here itself we can shift B to this. Okay, so you can see that again we are creating 5 more numbers. Now I have an option to print A comma B. If you require, you can print that out. Anyway, I'm not doing that. I'll directly go with, right, simply do A plus B. So that is the answer. Then you can do A minus B. Most of you have done this, right? That's absolutely fine. That's very good. Then A into B. Okay, it's a term by term multiplication, dot product. Then you can do the similar operation on division as well. Then the next question says A raised to the power 3, A cube. Okay, so every number, right, in A is raised to its power, raised multiplied by itself 3 times. So A cube is what we are trying to calculate here. Then the next part is to work out and understand how to apply the various trigonometric identities, trigonometric ratios, right? So array is given. You are supposed to use the same array. Let me copy that. So we created this array now, that is X. Okay, we can see that X here. So I want you to visualize the sine function, correct? So calculate sine, cosine, tangent of X element wise. Every element I want to find that. Okay, so let's try to do that. NP. Okay, so this is NP dot sine of yeah, You can enter X here. So it considers the values to be in radians and it's actually printing that value, right? So that's how it is. If you want the value to be right, to be considered in degrees, right? You need to convert them into the radians first. So that how do you convert them into radians? Again, I'll show you another method. That whatever we are expecting, if you want that to be seen, because I know that, right? If at all I write 45 degrees, I know a standard value of sine. Sine 60, I know. Sine 90 also I know. So if you want that to be printed, convert these and whatever is entered here, convert them into the radians first, because right, maybe the radians are going to give us the right answers. So how do you convert them into radians? It's like this: np dot sine of, I just have to write there is a x, I should multiply this by np dot pi, and I should divide that by 180. Okay, let's see. Now we see this is what we are expecting, correct? For 90 degrees, sine 90 is 1. Yeah, you can see that. So sine 60 is 0.8660. Sine 45 is 1 by root 2, 0.7071. And sine 1, it is closer to 0. So I am getting an answer which is closer to 0. So, right? So it depends on what you want. So you see here, in this case, line number 34, everything is being, the values of x are being considered as radians. That's why you have a different answer over here. But if you want, right, proper answer, right, it is expected that if you are expecting that 45, 60, 90 is actually, they are in degrees, you need to convert them into radians before you enter, because by default, np.sine expects the values as radians. That's all. Okay, but it's not wrong. I'm not considering that as wrong, whoever has written this answer. Okay, that's also absolutely fine for me. But I just try to make clear that if you are entering something in degrees, it's fine. Enter them as degrees in an array or a list, but convert them into radians whenever you enter into the sine function. This is what is expected. Okay. All right, let's go further. Let's do the next part. So that should be np dot cos x and np dot tan x. Okay, so given an array of x, convert the angles from degrees to radians. So just now we have seen one operation, right? But I'm going to tell you another point here. There is a built-in function which can do this job. All right, so first let me try to write these values. X is equal to np dot array of, enter those values, minus 180 minus 90 plus 90 180. This is the x value, and I'll call a function np dot deg. Yeah, so you can see that is a function called degree to radians, deg to RE. Simply call that. Okay, this is also going to do the same job. So minus 180 is minus pi, minus 90 is minus pi by 2, plus 90 is pi by 2, plus 180 is pi. Okay, yes, so this is new thing for you, right? Okay, please consider that, explore this further. All right, let's move to the next question, that is number 16, right? Given an array X, calculate the round seal floor of everything. Okay, that's very interesting. What is the use? You will understand. Depending upon your usage, you can use the functions such as round, seal, floor, etc. Okay, so this is the X. Now I'll call the first one np dot. This is round X. Right? So you see it is getting rounded off, right? Mostly to the closest integer. 4.1 is 4, 2.5 is 2, 44.5 is 44, 25.9 is 26, minus 9.5 is minus 10, minus 6.9 is minus 7. Whichever is the closest one, it is getting rounded off, right? So there is another thing that is called as a seal. Sorry. np dot seal of the same thing X. So seal is above. So you are rounding off to the next number only, irrespective of whatever number that you find. 4.1, though it is close to 4, you are rounding off to the next number because seal is above. So next above number is what it is being considered. Okay, always. So towards the positive side. So you see the number minus 9.5, which is the larger number than minus 9.5. It is not minus, it should be minus 9 because minus 9 is larger than minus 9.5. So the next number is, next integer is what you are going to, right, get as an answer. If your intention is to convert any fraction to its next number, larger integer, you should use C. Okay, and if you are not worried about the next number or not, whichever is the closest one you want to round off, means you should go for round function. Then there is one more called np dot floor. Okay, so just check this. Now you are converting to the smaller number than the given fraction. So the number is 4.1, it is rounded to 4, 2.5, 2, 44.5, 44, 25.9, 25, minus 1.1, which is lesser than minus 1.1, it is minus 2. That's why you are converting it into minus 2, minus 9.5 is converted into minus 10, minus 6.9 is converted into minus 7. So look at, this is a very big difference, okay? Right? The big difference comes between the seal and flow. So whoever has any difficulty understanding that, please let me know, right? Otherwise, let's go ahead. Okay, the next question is given two arrays X and Y, divide X by Y element wise. Okay, so element wise, I want you to divide. There is also want you to divide using what is called as a true divide. Also, you should perform what is called as a floor divide, right? So this is again, you are supposed to explore what are they, and then you are supposed to, right, perform the operations. Okay, so few of you have done that. I could see. Let's do that. So this is X and Y. I just want to check what is X. I also want to see what is Y. Okay, so X and Y. The first thing is np dot, it's called as a divide. Np dot divide, simply say X comma Y. You want to do this division, and this has to happen element wise. So 1 by 4, 2 by 5, 3 by 6 is the expected answer. And yes, you can see, yes, we are getting that answer. That is what is called as a true divide. Again, let's perform np dot true divide of X comma Y. Okay, so in this case, you can see that they're pretty much same. So true divide and divide is same. Let's look at the other one, that is np dot floor divide, floor divide, do the same thing, x, y. Okay, so in the resulting answer, you are getting an answer, the value will be floored, in the sense whatever you get, it will be converted into the lower number, right? So 0.25 is 0, 0.4 is also 0, 0.5 is also 0. Okay, so that's the usage of what is called as a floor divide. So perform the x to the power y element wise. So element wise, right, you are supposed to do this. So let's, okay, we have x and y with us. Already we have x and y. Let's just print out. So x is this, and this is y. And let me try to perform x y. Okay, also you can do another method. Some of you have explored this and found that there is a function called power. That's pretty nice, and you can definitely use x comma y. Okay, so you get the same answer, right, irrespective of which particular technique you use. Then let's move to the exercise number 19. An array x is given. If an element of x is smaller than 5, replace that with 4. Okay, and if an element of that is larger than 9, replace with 8. Yes, it's a straightforward question. I have seen that people used what is called as the if-else condition. Yes, that's a right answer. But the Pythonic way of solving this question is slightly different. Okay, you don't have to go with n number of lines of code here, right? So let me first write this, copy this x first, then let me show you. So you can see that this is the x that is being created. Now there is what is called as np dot clip. There's a function called clip. You have to tell that which is your array, what's the minimum number you want, and what's the maximum number you want. What it does, any number lesser than 5 will become 4. 4 or less than 4 will be 4, right? 8 or larger than 8, that is 9, 10, 11, etc., will be converted into 8. So this is what is the required answer. So just check. 22 became 8. 3 is 4 because it is less than. 66 is more than 8, so it is 8. 12 is 8. 1 has become 4, and 5 is 5 itself, because 5 is between 4 and 8. So that's the answer. So just remember, I want you to remember this. Okay, this is very useful whenever you deal with whenever you are dealing with outliers. Okay, so I have outliers like the complete data set is 0, 1, 2, 1, 2, 3, 4, 5. All of a sudden 101 comes, right? So you see that 101 is an outlier. Nowhere even if you consider the complete data set, you have all the numbers between 1 to 10, right? You may have few numbers coming up like 101, 85, so 1006, because of some errors in the census which you are using for, right? So, which you are using to measure this data. In such cases, this is very important. That's why this particular question has been added in this assignment. Okay, so after we finish this, in the sense after the today's session, I expect everyone to go through these questions in very much detail and understand. Okay, so how to use each one of them, very important. You are going to get another assignment very soon. Okay, right, within one class or maximum 1 or 2 classes, you will get another assignments for sure, right? That will be a next level questions, not simple questions like this. These are simple questions. Okay, you may have to apply whatever you study among these two different assignments plus the upcoming class whatever we discuss, right? So in pandas will be coming in the upcoming assignment question, right? So I think 2 or 3 more assignments are have been scheduled one after the other, right? So you may not get much time for submission also, right? So I expect you to be alert and right, understand everything so that you don't waste a lot of time searching the answers. Okay, so that's my that's why I told all these things in right in advance. Okay, so let's go further. What's the next thing? Use the functions length, shape on a given array X. How do you relate that with each other? All right. And what do you mean by n dimensions, right? So I just want you to type that and see, right? I'm not expecting any oral answer or any typed answers over there, right? I just wanted you to type that, and you should know how to type them separately. Okay, so that's the basic idea of this question, and I could see that most of you have done that. So this is the creation of the array X. Let's see. Okay, let's see the X now. Okay, after that, I wanted you to check out how the length function works. This is how you find out length of any uh, array. So it says that it actually gives you the number of elements. That's first thing. Then let's go to the next question that is asked. You are supposed to use the shape and the dimension. Okay, so the second one is, if you want to look at the dimension, it has to be x dot ndin. Okay, so check that. It says it is one dimensional signal, though there are 8 points. All the 8 points are along a row wise, or they have been arranged in a column wise, so the dimension becomes equal to 1. Okay, then let's say the x dot, so there is what is called as a shape. All right, so just see that this is 8. Right, so shape tells you how many elements are there in that particular matrix. So let's go to the next question. That is question number 21. So create a two-dimensional array called X ranging from -1 to 14 using arrange with the step size is of 0.25. Then split this array row-wise into 3 equal parts and print the result. Okay, all right, let's see how to do that, right? A few of you have tried this. Let's say the first question is X. Create an X that is equal to np dot arange starting from -1 going all the way till 14 with the step size of 0.25. So this is the first part of the question. Let's okay, let's visualize that. Okay, so -1 till 14. 14 is not included. All right, that's fine. Then I am supposed to split this into 3 parts. Okay, so this is how you do that. So x1 is equal to capital X dot reshape. I can say that it's a question. Let me read. Split this array row wise into 3 equal parts and print the result. So okay, I think 3. And how many entries are there? 54 plus 2, so 60 are there. 60 means I can split 60 into 3 into 20. Okay, let's just check this, and I'll say I'll call x1. Yeah, so you see row wise, cut this complete array. This is a single array. I wanted you to cut this into 3 pieces. So split this array row wise into 3 equal parts. 1 row, second row, third row, 3 equal pieces row wise. So 3 rows are there. So you can see that starting from here. Okay, that's not the answer. Sorry, this one. Starting from here till here, this is the row number 1. 20 elements are there. row number 2, the second part, and the row number 3. So altogether you have 60 elements. The 60 elements that are present over here have been split up into, right, 3 equal pieces, 3 rows and 20 columns. So originally you had 1 row 60 columns, you splitted that into 3 rows 20 columns, right? This is one way of answering. Okay, so you have any other answer you want to discuss, please go ahead, you can ask that question now. Okay, so that's the answer for, that's a key answer for 61. Okay, sorry, question number 21. Let's move further. We have another question that's coming up here. So, all right, so it says that already you have created a x right now. So the x we are talking about, the first one, x equal to np dot a range minus 1 to 14. So how do you find out the sum of each of the element, right? Sum of everything. Okay, so right, let's go to the first one here. So I can simply try to, I can try to do that using np.sum should work. Sum of all element. So you can check with x1 or x, whichever you want, you can try, because though I mentioned the x here, okay, use the array x created above to write the commands for the following. Yeah, so you can preferably you can try x1, but few of the questions may not be applied for x1. You can go for x. Okay, so the fundamental idea is that you have to understand how to use these functions. That's all. The first function is find the sum of each and every element. If you want to do that, it has to be sum. Okay, np dot sum. You got an answer. Let's go further. The next part is find the sum of all the elements row wise. Okay, so row wise means along a column I should consider, right? Every row I am supposed to add. So in a column you should come down. So this column direction is 0. I just have to mention that column np dot sum of x comma specified axis equal to 0. Okay, let's see that. This is all. Okay, if you go for x, it's a one and same. Let me try to go with x1, because x1 has many rows and many columns. So now you can see that you will get 20. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20. 20 answers you get, because there were 20 columns, 3 rows. Every row, right, row wise you are adding so that you keep 20 columns as it is. So these are the answers. Okay, the next question says that sum of the elements column wise. Column wise in the sense every column, right? Row wise in the sense like this considered, you are adding them every column, right? So the next question is column wise in the sense every column, right? You have to keep them. So these columns you are supposed to add. So column, next column, third column, etc. So when you add that, the answer comes in a column wise fashion, and only 3 elements should be there because there are 3 rows, right? So np dot sum of, I'll write x1 here because otherwise I will not be able to show you this part. So axis equal to, let's say 1. So see, only 3 answers because, right, there were 3 rows, 20 columns. Every column wise you are adding, in the sense column, next column, third column, fourth column, fifth column, like that 20 columns you add. So you have only 1 column remaining. That column has 3 values corresponding to each of the row. Okay, all right, so that's the next question. Then find the max of each of them, right? Then maximum element and minimum element in each of the row is also asking, I guess. So let's do one thing directly. I'll try to answer this. So that is x1 dot max is this, x1 dot minimum, and I can also show you np dot, next question, minimum of all the elements each row, in each of the row, which is the minimum number I want to find out. Okay, so np dot min of x1, specify axis equal to 0. Okay, so that's how you try to find out this. If you want to find out the column way, you can also do that. np dot minimum of say x1 comma axis equal to 1. Okay, only 3 elements. All right, so every row, whichever is the minimum value, that comes at the end. That's how you try to answer. Then the mean value, right? They're asking row wise. So every row you consider, and I want one minimum answer coming at the end. So that is np dot mean x1. Okay, when I write 1 here, right, only 3 values come, right? 3 values come. That means first row 1.375 is the mean. Second row 6.375 is the mean. Third row, that is the mean, 11 point something. Then one more question. I think the last question is standard deviation, right? I wanted you to explore this and get an answer. So yes, few of you have done that. np.std, right? np.std, that is x1 and axis equal to, it says that column wise, so whatever is the number of column, that should be the answer. That's why I'm writing that as 0, axis equal to 0. Axis 0 means every column wise you are trying to do something. Okay, so these are the various answers that we were expecting. Again, these are simply the key answers. Okay, they are just the key answers, and there may be many other versions of the same thing can be done in using different ways, right? Those who have tried that out, and if you have got a result, and if at all you want to discuss about that, yes, we can go ahead. Otherwise, yes, this is the end of the assignment number 1 from NumPy.